All right, we're going to get a little more technical now. We're going to talk about, we talked about that concern about, the quality of data collected by volunteer monitoring programs. And so that's what Paul and Eric are going to work on for us over the next hour. They're going to talk to us about how do we ensure the quality of the data that are collected through the MiCorps program. So this presentation is going to be co-presented by our Streams program leader, Paul Steen, and then joined by Erick Elgin, who runs our Lake program. So I think I'm handing it to Paul right away.
Sharing my screen, of course. All right, I think that's working, right, Joe?
Looking good. Thanks, Paul.
Okay. So, I have a lot of adrenaline running right now, so I apologize offhand for talking too fast or stumbling over my own words, and I'm going to try to go slow. But you have to understand, I really like talking about data, so it gets me really excited. And hopefully that I can wear off on you a little bit about that. I'm going to start off by talking about the stream monitoring program and the data we collect and some of the thoughts that go behind maintaining the data quality in the stream program. And I'm going to pass over to Erick to do something similar for the lakes monitoring program. So this is, now we're starting to get into more complicated topics. The particular audience for this talk is those people that run one of those stream monitoring programs. That being said, I'm sure there's aspects in here that will appeal to a broader audience. So, don't tune it out. But I'm interested in what everyone thinks about the stuff that I'm going to present in coming up here. So. Yep. So, but my particular topic or my particular audience that I was framing this toward was those program leaders. So, just so you know, kind of where I'm coming from when I start talking about this stuff. So you just saw this slide, but just in case you've missed earlier today when we talked a lot about the basics of what we're monitoring for in the stream monitoring program, we're looking at macroinvertebrates, and macroinvertebrates are a good proxy for stream habitat and stream water quality and the combination of those two things. So macroinvertebrates live in your creek all the time. That's their life. So if you have a creek where you have a rich diversity and abundance of macroinvertebrates, you have year-round conditions that allow for survival. So the more of these you find, the healthier your streams are. And because it's an easy process to go through, and it doesn't take too much training to learn how to identify them, it's a good volunteer-based parameter for people to engage with. So that's kind of just the background in case you missed earlier today why we're doing this. But now we're going to talk about the data. And there's a lot of considerations when it comes to dealing with data in a volunteer-based program. There's a certain kind of, I guess, burden placed upon us since we work with so many volunteers in collecting the data that we just need to be above and beyond maybe what professional organizations or a professor or the state would necessarily do for their data, because a lot of people are going to be looking at our data and questioning it, right? So we need to be upfront with how we're dealing with it so that there's trust built in. The stream data has thousands of records. The CLMP is hundreds of thousands. So this is just the sheer quantity is overwhelming, which means we have to have certain standards set up to prevent these bad data points from kind of coming through and eroding our reputation. As a volunteer, there's something for everybody to to think about in that aspect. With the CLMP, there's things that you can do to improve this program-wide data quality. As a volunteer stream monitoring program leader, there's things you can do. And there's things I can do, and there's things Erick can do. And when we're looking at the back end, our goal is to say something valid about our results. No scientist wants to leap to conclusions based on erroneous data that eventually is disproven or ends up embarrassing yourself. So this is it's just a high desire to make sure we get this right. However, environmental data is just terribly messy, and it makes all of these decisions difficult. What can I say about macroinvertebrate data? It's whatever I say. It's gonna be just a messy, complicated thing to say. And the same thing with the CLMP. The data is messy. I mean, by messy, I mean just highly variable. Just so many ups and downs in it that we want to make sure that we're properly what goes into our database is actual reflections of reality. It's an actual reflection of the ecological system, and not outliers or not mistakes. And sometimes when you have highly variable data, it's hard to know when something's an outlier or when something is a mistake. So there's these need for data controls to make sure that those things don't get through. And my final point as an introduction is it's really like you're putting together a puzzle when you're dealing with this data. It's I try not to think of it as a game, but I like video games. It's all these pieces coming at you from different angles, and it's interesting and it's fun. And I'm gonna show you some stuff in Excel, and my hope is to show you that Excel is fun and interesting, and not just for nerds like me, but it's something that everyone can kind of engage with as a problem-solving exercise. So dealing with data decisions, now I'm specifically talking about some stream issues that come up when we're looking at our stream data. And this graph would be something that our program leaders produce. It's a graph of data through time, and how are our insects changing in this particular stream. And it sure looks like they're increasing here. That's what the graph would indicate. But you'll notice that 2010 data point sure is a lot higher than the others. Is that an accurate reflection of reality? Is there something else going on here? These are the kind of things that I think about. Is your site actually getting better here? Or are you dealing with a team of exceptionally enthusiastic volunteers that aren't quite to doing what you told them to do? We have set directions that we're asking people to follow, but as a manager, I'm usually back in the office trying to organize logistics, and I have to trust my team that's going out to a particular place that they're gonna do what they've been instructed to do. So when they come back with an odd result, I have to think about if this result is a valid result. Are they even in the right spot, right? Like, questions like this are the kinds of things that you have to answer. The smaller your program is and the more you're actively going out with the teams yourself, it's less of a problem. But as programs grow, you can't go out with every team necessarily, so you have to kind of trust in your training that you give into people and your ability to look at the data on the back end. So this is one example of stuff that comes up. What's going on with this site? What's going on with this site? Look at 2025 on this particular graph, where it looked like the stream was getting better. And but suddenly your volunteers come back with a sample where that it just drops off hard, and you're back at numbers that you haven't seen since 2011, 2012, and you thought the stream was getting better, but now suddenly it's just as bad as it was a decade ago. And is it really getting worse, or did something else happen? Is this a weather situation? Did was your were your volunteers sampling in a, you know, in a creek like this? This is the Huron. This is the Huron River in the spring sometimes, and the picnic tables here are in a grassy lawn, right? So you would not be sending people here to sample a macroinvertebrate community, and they're pulling out earthworms in their sample instead of the aquatic insects, right? So when things get this extreme, you pretty much know about it. So this is kind of an extreme example. But sometimes you go out to a creek and it's flowing maybe 30% higher than it normally does, and maybe it's still not a reflection of like the reality for that for most for that stream for most parts of the year. So you kind of have to watch out for this. Like where is the stream suddenly not reflecting its normal conditions? And just in terms of interpreting the data, maybe the stream still is getting better, but if you're sampling in really high water, it may have a sudden drop off. Um, Final example here. Is this a trend seen in the data truly reflective of real life? This particular stream seems to be getting worse over time. The insect families are going down, I think, but this is what I mean by messy data, right? You'll have a peak, you'll have a drop. You try to find this kind of this trend through the middle of the data over time, but it's just hard to know. Like statistically, is it going down or is it staying the same? These are things that, as a program manager and a volunteer manager, that you have to these are issues that you have to grapple with. So one of the ways that in MiCorps that we deal with these issues is by working under a QAP. Jack earlier today talked about QAPs a little bit, and that was kind of a good intro. Each one of our programs operates with this written set of instructions. This is our plan for making sure data quality is followed for our monitoring. I like to say a QAP can be a guidebook for your future replacement. You may have all this knowledge internalized for yourself and how you run with your program, but by having this written down as a document that's maintained over time, then whenever you decide to leave your current position and someone else comes in, it maintains that continuity, and so that you know that stuff that the data that you're collecting now is the same as the data that was collected before you were hired 10, 15, 20 years ago, and you're able to have confidence in your long-term data set. A QAP addresses all these things, why you monitor in the first place. It's usually the introduction to a QAP, where you're monitoring, your site list, and then the key part, how you monitor, what are your specific procedures, how do you handle your equipment. There's this data assurance checks, which is what I'm going to be talking about in the next slide. Like what things do you do when you look at your data so that you can be confident that it was done correctly? How do you share your data? So all important parts to keeping the long-term data quality of your for your program. So QAPs work, right? They do this. They provide this long-term reference for you, for your replacement, to make sure you're doing things consistently within your stream monitoring program. In MiCorps, all of the MiCorps affiliated organizations, the Watershed Councils, the conservation districts, we're all required to keep these QAPs updated every 2 years. That is a prerequisite for getting grant funding. So we're making any organization that's like active with us, that there's active money that MiCorps is giving to this organization, needs to be operating under one of these updated QAPs. Now, a lot of us use the same general language in a QAP. There's a guidance, so when you're writing one of these, you're not just like out on your own doing whatever. But like MiCorps provides a certain set of talking points that everyone kind of uses that are the same, and that's what I've called out here in this paragraph. So this is a data quality check that MiCorps groups have in their QAPs. Now the question is, do people follow this? And what I want in this presentation is to highlight like how this particular check can be done, because I find it like really, really useful. So this particular check in a QAP is talking about the relative percent difference. And what it's saying is that there shouldn't be a difference of more than 40% when you're looking at your current measurement versus the long-term median or average of your past measurements. Now, if you do exceed 40%, it doesn't mean you throw the data out. It says here in the rest of the paragraph. What it really means is that it's a trigger to look at the data more carefully to make sure it was collected properly. That 40% number allows for a lot of that up and down variation, but what it does is when you have something that's really high off, then that's a trigger for you to look at it more carefully. So let's take a look at some examples of how I do that. And to do this, I get the fun task of showing you my Excel spreadsheet. Hopefully you can all see that still, right, Joe? That still looks good.
Yes, it looks good.
Or Eric. Yes, thank you. Eric, you're my moderator. Okay,
Together.
So this is how I look for that 40% difference in my data. And to do this, I want to just share this spreadsheet a little bit. I have a spreadsheet that has all of my data in it. Right now it's got about 3,000 rows or something like that. So each one of these rows represents a different effort that a team did to go out and collect that information. So you can see here like the metrics that are computed. So we're counting the total number of macroinvertebrates found, different counts, total diversity, all the different types of groups, the families that are just insects, the families that are EPT, those are some of the more sensitive, the mayfly, stoneflies, caddisflies. There's my MiCorps rating on here. You can see I've set it up to just auto-calculate with a very messy formula, but it works. I have all of my raw data, so all my bugs, all right? So everything just gets entered here, and this is where the data sits for me to work with. Okay, but now when I do my data quality checks, I come over here and I have this nice spreadsheet that I've set up for myself. And what it does is I can pick any site and then any season to just pull those metrics directly. So now I have a couple examples I have to remember which site I'm going to look at here. All right, I'm just going to show you site 1. All right, site 1 in the spring. So, great. Here's site 1 in the spring. We've been sampling here since 1994. And this is then what the data looks like. It's those graphs. We've seen, it looks like abundance over time here is holding pretty steady. The total number of insect families seems to be holding steady, though this past time we got a high point here. So the question is, is this high point out of the unusual for this site? So I've set up this fun check. If I set this to 2025, I'm sorry, this is, okay, the most recent data point is 2023. So I'll set this to 2023 to check that particular data point. Okay, so what this does here is just automated, easy formulas, really. Gives me the median that I've seen. And then using that 40% difference, what would be the lower end of that 40% difference and what would be the upper end of that 40% difference. Right, for 2023. Okay, so we're checking this dot right here, right? And we're only 1% off the median, so clearly not an issue. We're absolutely within the bounds of it being expected. However, what's interesting here is that we are outside the bounds of what we maybe would expect for the insect family count. Our data point is 17. We found 17 different insect families. We would expect to find between 6 and 15. And so we're 55% outside the bounds of what would be maybe considered normal for this particular site. So is that an issue? Does that mean, oh, we're outside the bounds, I'm going to throw away this data point? No. What this is now I have something to check. I'm like, okay, we're getting an awfully high result here. Can I find any reason for it? So I would look at the data sheet and see if the team reported anything weird going on at the site, if they collected it weird. Sometimes our teams get really, really big because we might get a scout troop that wants to participate and we send them out with our train leader, train collector, but they might have 8 pickers. And if they come away with too many insects, that can cause trouble. Like they might be essentially outside the bounds of how we normally want them to collect the sample. However, for this site, it's not like they collected a whole bunch of extras. They're right at around 100, which is kind of what we ask people to shoot for. So there's no reason to not keep this data. Like, here's some other metrics. It's falling right in line. There's our MiCorps score falling right in line. So we had one metric that was outside the bounds of normal, but there's no reason to strike this data point. I would consider this totally within the bounds of messy data, high variability, but it's nothing unusual. Okay, so that was just to kind of show, like, usually that's your result. And 90% of the time, a little more than 90% of the time, that's my answer is, okay, we're going to keep this data. There's no direct signs that it's bad, but you can come across some things that you can definitely see some issues. So I'm going to try site 4 in the fall. I always separate my data points by the season because I just have found through time that spring and fall just tends to just be a different enough of a community that you get cleaner results if you look at them by season. Yeah, I already see Tyler. I see your question. Can I have the spreadsheet? Yeah, I want to put this in a framing that will work for everybody, and then I'm going to share it with everyone who's interested. Okay, so now we have a more obvious problem. We're going to check 2010. Okay. Normally, so I want my teams to collect about 100. This team that went out in 2010 came back with 397. So they collected about 4 times the amount of insects I want them to get if they were following this procedure correctly. If I was out there with them, I would have stopped them and said, we're only collecting for an hour. We're only the person's actually in the water for 40 minutes. The team might collect for 60 minutes picking. I don't know what was going on with this team. And now that it's 2010, it's kind of like too late to go back and check. Like, I didn't find this problem till recently. So it's just like, if I had this tool back in 2010, I could have caught this a lot sooner. But now I'm just guessing as to what the problem is. But anyway, and whatever happened, they collected way too many insects. They collected 220% outside the bounds of what I would say is acceptable. And then you can see how it affects the metrics. So typically, the more insects you collect, the higher any of your metrics go. which is why you need to control yourself. You can't just be out there all day collecting, because then that would mean that every team would always have to be out there all day collecting to keep things consistent. So we have these hard boundaries to make it a more realistic volunteer program. So they're, in this case, I would say this is an outlier, and I would end up cutting it, and maybe even it sure looks like the stream is getting better, and maybe that trend is entirely based on this one bad sample. So if I now started maybe I got on a radio interview and I was bragging about how the stream is getting better, and we're really excited to see the improvements in water quality at this site, and I'm saying all of that based on a bad sample. That it just doesn't feel great for the quality of my program or maybe future work that I want to do. So you never want to oversell your improvements. You want to be able to say something that's scientifically accurate. So in this case, what I would actually do is I can't cut it there. I would need to cut it out of here. So I would cut that data point, and I have a whole side spreadsheet here for my outliers. I never delete any data. It still could have some value. I don't necessarily know what it is offhand, but there's value in saving this. So I would into this. It's no longer going to be in those graphs, and I don't have to worry about skewing my conclusions later on. So actually, I'm running out of time, but I had like 4 more examples. Maybe I'll give them at a later point in a different presentation. But this is the type of thing that that 40% rule, which is in all of your QAPs, that 40% rule can be used to help you find mistakes. So with that being said, I do have to hit my conclusions before I run out of time here. So following up on these errors, talk to your collectors. You're not there for everything. They are. If something odd happened where they went outside of what you're normally asking them to do, they should know. They may think they did everything perfectly, and then it's just another data point for you to be like, okay, well, I don't have any real reason to strike that data point, so I'm gonna keep it. Usually what I see is that bad weather is where you get these huge drops in your record. If something is honestly getting better or getting worse, it's usually much more of a gradual change in your data, either a gradual change up, a gradual change down. And maybe you take out a dam and you will have a huge change, but that's like a big thing that you would know about. If nothing obviously has happened at a stream, I don't expect you to have more than these gradual increases or decreases. If you know that you have a problem team, feel free to retrain them, give them the directions again and again, go out with them eventually if this is a problem that keeps on continuing. It's important to point out that if you're just starting your program, you're not going to know what a good long-term median or average is for your site. You really have to keep all of your data no matter what for at least 5 years. And then once enough time has passed and you have enough samples, you'll better understand that site to understand if you're outside the bounds of normal. And you can always strike out if you find later that you have a bad date from a bad sample from 5 years ago. You can always take it out at now, and then it's not going to impact how you think about that site going forward. And if you know that you've entered bad data into the MiCorps database, email me. I can take it out from that long-term storage, so then other groups and Eagle staff and other people interested in our data aren't using those bad entries. Okay. Wrap up for Paul. So we're at the start of this 5-year period where we just signed a new contract, and I have a time ahead of me, and I can think about these issues. So I'm always looking for improvements in this program. Here's some things that I kind of taking on for myself. I want to make sure all our groups are using that standardized QAP language. So I'm probably going to go through the QAP guidance and make adjustments so that we're all using these same data checks together. I want to think about what other metrics, what other insect metrics do we want to use besides water quality rating? Water quality rating is what we all use right now, but there's other metrics out there, like from Eagle's Procedure 51 has its own set of metrics. Can we use those too? And if we all use them together, then we can have similar ways that we report things together. Just creates more standardization between our groups. How to detect significant trends. I didn't even talk about it in this presentation, but I have lots of ideas about how we all could use some easy statistics to look for significant trends, and all do it the same way together. I also want to turn this spreadsheet into a tool that all of us can use in similar ways, and just kind of further build. The more I think that our different groups can do things the same way as each other, I think the better for the reputation of the program, and it would increase its data use. So that's what I would really want to do in the next few years. And all of you guys, give me your ideas and opinions. I'm like in this learning process the same as anyone. So I'm interested in trying out different ideas to try to accomplish these goals. So let me know what you think, and we'll kind of like work on all this together. So that's it for me. I'll stop sharing so Erick can get in, and while he's doing that, I could probably take a question while he's thinking.
Thanks, Paul. You did a great job there, Paul. We appreciate that overview and also the demonstration of your spreadsheet. There aren't any specific questions about stream quality control left that you didn't already touch on. And I know there was some interest in getting a copy of that spreadsheet, which you already offered to do for folks if they're interested. But there was one question in the Q&A more related to lakes, and we'll let Erick get started. And if it doesn't get answered as he's going through, we'll make sure to answer that question in the Q&A box.
Great, Erick, all you.
Thanks, Paul. Yeah, I agree. Wow, you got me excited about maybe community indices that we could look at with macroinvertebrates. How fun would that be? Like Paul, I also love data, and Excel spreadsheets are wonderful. So I am building off of what Paul was talking about with streams, and I'm now going to spend some time looking at the CLMP and taking a broader approach. Paul gave a great intro on citizen science data and the need for high quality. And Joe talked about in her MiCorps 101 how high quality our data is and how respected it is. And so I'm going to talk about the measures that we have and the actions we have that happen throughout the data collection process to ensure as high quality data as we can. And so let's head into that. Oh yeah, so quick introduction. My name is Erick Elgin. I'm an aquatic ecologist with Michigan State University Extension's Center for Lakes and Streams, and I'm the CLMP Lake Program Manager. If a lot of you volunteers I see on the participation list are volunteers, and people who are not, I'm the person who I'm here for you to answer questions and help move the program forward throughout the course of the year. Always feel free. There's my contact information. I have a great job where I get to work on lake conservation statewide from the CLMP's perspective, from shorelines, lake sheds, and so forth. So now let's get into it. Long-term lake monitoring requires consistency in protocol and collections to maintain data quality and reliability. What this means is, so this graph here is showing one lake and its Secchi reading through time. Every bar on this graph is somebody dropping a Secchi disc. And so it's flipped upside down. Imagine somebody's boat in 1984 was sitting right here. That's what this part of the graph is representing. And they drop a Secchi reading down. And that's what their reading is, around 6 feet on that particular day. And why this why this consistency in protocol and collections is so important is because long-term data, we want to be able to compare apples to apples through time. So that SECI that was collected in 1974 is the same protocol that a volunteer is using in 2025. Also, between volunteers, as you heard earlier, with it takes generations of volunteers to collect data like this on our lakes. And so there's different volunteers that are collecting this data. And so by having consistent protocols and quality control throughout, we can maintain that apples to apples comparisons, even though the volunteers have changed. And then one other thing is we want to be able to compare lakes between each other. And so making sure that the SECI that is being collected on this lake, Long Lake in Iosco County, is the same as Duck Lake in Muskegon County. And so that we can look at them together and make some good comparisons. And so, as Joe mentioned, the MiCorps CLMP is a respected and well-known data set because it's so rich and has a tremendous amount of information since 1974, with parameters being built throughout time. And Joe kind of mentioned some of these, but I just wanted to show a little bit more. It is incredible. I pulled this data last year, and so now it's even more. But it is incredible to look at the CLMP's rich data set with over 100,000 rows of SECI measurements, 4,000 spring phosphorus, um, over 1,000 temperature and DO profiles, which is incredibly valuable because that's something that is all of these are needed, but it's amazing to look at our temperature and DO profiles and how that is so useful to so many people. And on this histogram chart on the bottom right, what we're seeing here is the number of lakes that have been sampling for a chunk of years. And so, for example, most of our lakes that have ever been in the program have collected between 1 to 10 years of data. But as we get more and more, it is impressive the sheer amount of data we have for some of these lakes that just would not have this data otherwise. And so we have over almost 200 lakes that have between 11 and 20 years of data, all using the same protocols, all with the same data quality assurances throughout. And then all the way to we have almost 10 lakes that have been collecting for almost the entire 50 years. And so, why, since we're talking about quality, data quality, why is it that we need to put so much emphasis on data quality? And that is because error happens. The process of collecting a sample all the way to that now sample becoming data and into our database, there's many steps where error can occur. And so it is up to all of us to work together to create this good piece of data that is going to be embedded in this database, hopefully forever, or whatever forever means. And so I like saying it takes a village to raise a data set, and that our data quality is a shared responsibility where we do a lot behind the scenes, as even Paul was mentioning on the streams, and we're trying to find things. I'll describe some of the things that we've done. But also, we all know that you care a lot, the folks, the volunteers who are on the water collecting. And so being equipped and ready enough to collect and do the complete process to protocol is important for all of us to do to get that high quality data. And so now the next bit of the presentation, I'm just going to walk through kind of these broad categories of from collection to data entry to data quality assurance at the end. And I'll just talk a little bit about some of the measures we have. We have a bunch more. I'm just going to kind of gloss over them to get a sense of how serious we take data quality and the things that we do to keep our data quality high. And so, the most fun part of being a lake monitoring volunteer is to go out into the lake and collect samples. And the top thing that we can do to ensure high quality is to provide many avenues of high quality training and training devices and training materials so that people are following these pretty strict protocols and procedures and schedules because we're, as volunteers, we are using professional um, protocols. And so training is of utmost importance to have quality data. And so in the CLMP, we do this in many different ways. Joe talked about them a little bit. We have an in-person training um, annually with the Michigan Lakes and Streams Association's annual conference. We have usually a few days before or after that event, we have a live virtual training where we do the entire training for every parameter and we record those and put them on our website. So now you can refer back to them. Let's say one volunteer had to work and missed listening about how to collect chlorophyll. Well, they can go back and see that very training. Um, and so that's helpful. Now we also have very specific videos that are more new and they are directly on the protocol. Like, how do you collect chlorophyll? This is how you collect chlorophyll. This is how you filter that chlorophyll step by step by step. And those videos are now more precise and quick so that we can consume this information and be brought up back to speed or see the nuance involved when reading a protocol. And then, of course, we have written materials because some people do better with following written protocols and reading. And so we have written protocols, we have written reminders and tips on a whole bunch of things. For example, for our exotic aquatic plant watch, we provide a laminated white sheet with ruler bars so that we can volunteers can take pictures and then send them to us so we can interpret it. On the back side of that, there are tips on how to identify every single species, those 5 species that Joe talked about, on what's a quick way to identify Eurasian water milfoil, for example. We also provide frequent communications. And so I'm going to talk a little bit more on the next slide about schedules, but there's certain times where we ask you to collect summer phosphorus and they're 5-day windows for you. So it's quite tight. And so we have that in the protocol, but we also send out frequent communications so that people be like, oh yeah, that's right. I have to collect this weekend, which is helpful to create high quality data, because if you start to deviate away from that collecting window, now it's like what Paul was saying, we have to start to interpret, well, is that data comparable apples to apples through the years, or is it now saying something else? And then also we are always available. This team that you've been introduced to today, we are all available to assist throughout the season, answer questions, get to things before, making assumptions may not be the best route. And so we like to be easily approachable, and we are easily approachable to reach out, and so we can answer before any mistakes are made. Just one thing that we've said in any sort of scientific collection, no data is better than bad data. Bad data can be like if it's, well, I don't want to go out to the deepest location, I'm just going to collect off of my dock. So that would be considered something that we don't want, because that can be very different for many reasons. And so to keep data quality high, if you can't get out onto the deep part of the lake, we'd prefer just not to collect anywhere else. So still on the collecting samples, thinking of our procedures and schedules. And so, like I mentioned, in order to, I'll use summer phosphorus as an example again, to have apples to apples through time, we want to be capturing our lakes for summer phosphorus at the height of summer stratification. And so we give a 5-day window to collect that data. And that's so that through the years, through the decades, we can be very certain on what we're comparing to. Now, if it starts to deviate, so because what could happen is like, well, why don't it's more convenient for me to collect in July and not in September like I'm supposed to, and those numbers can be very different. And so that's why we have those tight windows to ensure the quality of the data. We also have some equipment. So we ask our volunteers to look at and inspect their equipment, like their chlorophyll equipment. Are the syringes all intact? Are there the O-rings all still good? And so we ask folks to keep equipment in tip-top shape. We also do our part. So our dissolved oxygen temperature probes, which is right now YSI Pro 20s, Tamara and others do a lot of work at doing annual maintenance to keep those in a consistent shape, good shape, so that they're ready for the next year data collection, so they collect at a steady way. We also have designated sampling materials that are sent to you. So using phosphorus again, phosphorus, the lab analysis is quite sensitive. And so if you collected phosphorus in your lake with a coffee mug and poured it into a bottle, you could have contamination from that coffee cup. Or if you use some other random, you use a Pepsi bottle, there can be contamination of phosphorus in that bottle. And so we send designated, properly cleaned bottles, send them to the volunteers. And we don't send it to them, to you all 6 months ahead of time where they can get kicked around and maybe open up and the bottle cap open up. Instead, we send it to you in phases. And so we'll send you a spring phosphorus sample soon before spring phosphorus is collected. And then we send a summer phosphorus soon before summer phosphorus is taken. We also have a lot of quality control samples. And so Paul talked about relative percent difference and just comparing between replicates. And so that's what we have multiple different measures for. I won't get too much into it, but we ask you to collect 2 samples of chlorophyll A or 2 samples of phosphorus at the same time. Those get sent to us, where then of the whole population of those samples, 10% or so get analyzed, and then we compare them to each other. And so those are field replicates where that phosphorus and that chlorophyll is collected in the same point in space and time, and they should be relatively similar. And we look at that to maintain quality. We also have side-by-sides. So that's what we call getting visited by one of us. And so being part of the CLMP, you might get visited by Joe, Tamara, or myself, and others, and we'll head out to a lake and give you now hands-on training on your boat, on your lake. It's great to improve the quality in that way, but then also there's professional replicates being taken. So Tamara is also taking at the same point in time in the same location as you, where we can then compare those samples as well. Moving away from just chlorophyll and phosphorus, there's also other quality controls. So we require, of our samples, that is, we require, if in the exotic aquatic plant watch, if you suspect you find Eurasian water milfoil, for example, that you take a picture of it and send it in with your data so that we can confirm, Joe or I will confirm, is that indeed Eurasian water milfoil. So, you're collecting data, but you're also at that very time also have a physical data sheet where you're writing and recording this data down. This is another location for error to occur. And so, for example, if you look at this bottle right here, you can see this is a label that looks like it's a little hard to tell what lake is this from, when, and this is a problem where there was an incorrect pen used that the water just leached it off. And so we give specific guidance on what the proper pens are. So for example, fine tip Sharpies are wonderful. Once they're dry, they're typically there and not run on this more glossy label that we put on our bottles. And so we know this, we give guidance. We also are carefully have designed our data sheets with asking for information that we utilize. And so sometimes it might seem repetitive, and it is repetitive, but each thing we utilize at some point in our data control. So for example, on the backside of some of our data sheets, we require you to draw a image of your lake and then where you sampled, which should be over approximately the deepest part of the lake. If we find some weird thing in your data, we'll look back at this, your line drawing, and see where it was approximately collected to see if that was a problem of why we might be seeing an outlier. Also, if a lake hasn't been in the system for a long time or there's a new volunteer and we're getting some strange data, we will refer back to this and for many other reasons. And so what we see here is a mistake where unless this lake is a square and there's our deepest location, I think this is um, needs a little bit of improvement because we do use this for data quality checks. We then take all of these data sheets and we keep them safely at the Eagle Laboratories, copies of them. But recently we have also been making PDFs of them. So we scan every single data sheet so that we can refer back to them. And I'll talk a little bit about why we refer back to them. So now there's the sampling, handling, and analysis part. This is you're sending your phosphorus sample to us. We're holding these samples and getting them ready to be analyzed. And so what happens is that things come to us. We confirm that those sample labels and those data sheets match. So we're looking at dates, we're looking at names, we're looking at is this the correct lake, all these sorts of things to making sure they match. And then also we're looking at that physical sample. Is the uh, is the cap to the bottle cracked? Because when it was frozen, it expanded too much and broke the cap. That would impact potentially the quality of that data. And we actually throw that out because of that potential um, of contamination, which we would not be able to determine out. And so that's not even analyzed. Um, or we look at for other things like, for example, here, if anyone has collected chlorophyll on the call, I know we're in a webinar, but I'm going to ask the webinar world, do you see a problem with these chlorophyll tubes? And what is missing? And if you said need to be wrapped in foil, you are correct. And so these were not wrapped in foil, and so therefore these are compromised, and we would have to reject them as well. What's great is this partnership that Joe and Tamara have talked about is this great partnership of what MiCorps is, and that one of them is that we utilize the Eagle State Laboratories. And so all the analysis is done in a standardized way using standard protocols, looking at replication within the laboratory, using many different quality controls that are standard in a lab. And so that's really wonderful. And as I mentioned, plant identifications are also confirmed by us. And I'm just glossing over, there's other things that we do for dissolved oxygen, other things we do for score the shore. And now looking at data entering, this is another place where errors or mistakes can be made. You can imagine you're entering data for quite some time and things can happen and you put in too many zeros or you spell something wrong. And so we have some designed controls in our online data entry process. So for example, first, if we make it as easy as we can for the online entry form to mirror the data sheet. And so you look at your data sheet and you just goes through that same sequence of items we're looking for. We have some must fill out required information. And so if you miss something that is required, you will not be able to submit the data. And we also have some maximum value restrictions. And so you maybe wanted to put 10 feet Secchi, but you accidentally put in 1,000. Our data, our data entry process is designed to say, oh, something's up there, and it would be you wouldn't be able to submit it until you updated and fixed that. Also, as you can see with my Santa theme here is, making a list and checking it twice, entering data and checking it twice. When you first enter data into our system, you hit submit. At that point, it's not submitted into our database. Instead, it now goes to a place where you can check it twice. And you have a chance to look at that data on a new page in a new different way to make sure that it reflects what your data sheet says. Then you hit confirm. Now at that point, it goes into our database and you can actually do making a list and checking it thrice. Is that 3 times? At this point, I encourage folks to go into the database and view your data you just put in, just to confirm that it's there, went into the right lake, and it looks correct. And so I'll just say, so there's our Santa with a Secchi and the data sheet that's fully filled out and checked at least 3 times, at least twice and maybe 3 times. Okay, now looking at the quality control of entered data. So a team of us behind the scenes, Paul has been doing this for many years, is that we look at your data in a composite. So we're looking at all the data, and I will look for extremes and outliers just within that. So if we do see a Secchi, for example, of 150 feet, we will look at that. And make sure where you'll find out what the mistake was. Maybe it was supposed to be 15 feet and not 150. We also then create individual lake reports. And at that point, data is looked at broadly on a per lake basis. And so we're able to see some potential errors that might develop. So if we have, just like what Paul was mentioning, 5 years of data on let's say Score the Shore. I haven't talked about Score the Shore yet. 5 years ago, you did Score the Shore, and it was a certain number, and now it was triple that. That I guess is possible, but there likely might be a mistake in there, and so we will see that at the individual when we're developing the individual lake reports, and then from there go through data sheets, possibly contact the volunteer, look at the data entry, see what might have happened. We also, I mentioned those field replicates or those that side-by-side professional replicates too. And so we take a look at that suite of information and take a peek. Like Paul said, sometimes you might have something that's quite a bit different where the field replicates are different, as in, but which doesn't mean the data is bad. It means that we look at it more carefully. So for example, if you are 0.001 milligrams per liter and on one sample of phosphorus, and on the other one you have 0.002 milligrams per liter, that would trigger us to look at it, but ecologically and understandably that difference is not very big, and so we would still look at it to make sure, but that would likely stay into the system. And like Paul said on one of his last slides, is that we're always looking for continual improvement. We're always learning from you. We're learning from each other. We're learning from the professional network that's out in the world today. And we take that and we're always evolving and improving our system. We slowly evolve our data sheets to be more intuitive or easier to write in. We always add or subtract things when needed, while understanding it is a long-term program, so there's consistency that way. Um, we we look at our professional assessments, we look for volunteer feedback. And just to let you all know, for example, we understand that our data entry online is clunky in some ways and can be improved. And so just to let you know, updates to the data entry is in the works, and hopefully in the next handful of years we'll have, or not hopefully, we will in the next handful of years have an update to our data entry system. And so just to end, we're really committed, and I know all of you are, to maintaining data integrity, and because this is such useful information, and it is incredible. As Paul said, ecological data can be up and down. If you look at this lake, you can see that there's this very distinct annual pattern that's happening here in the early years at least, and maybe kind of in the later years. And it's just incredible to have such high quality data collected on these lakes through time, so that we can, put the present into better perspective. Because if we just collect today, that's great data, but to have something from the past to put that data point into perspective is very powerful. So thank you very much. I think there's not much time for questions, maybe.
I might give you one, and then we can answer the rest. We can write some answers to the rest because there are a couple lake related quality control questions in the Q&A. So I'll ask you this one. It's from Mike, Erick, and he says, on the summer phosphorus collection window, there appears to be an artifact in the UP where the last two collection windows are only a day apart. And I think it's actually talking about chlorophyll, not phosphorus. Is it possible to have the last two collection windows sampled only one day apart? This seems odd.
One day I would have to look at that spread, but yes, so we base our collections for the last, well, phosphorus and when chlorophyll is collected based on latitude. And so we are trying to capture those measurements during the stratification period. Um, and so the UP does have a situation where the last sample is collected close to the phosphorus is collected close to the chlorophyll.
Right, which
I
is
get,
why, yeah,
Joe,
our
what you were,
volunteers here see, oh, our September sample, it says, but it's the fifth sample. It's August for the
yes.
UP, so they align with that, so you can do your chlorophyll and your phosphorus at the same time. And there can be some explanatory value to that, to having those data collected at the same time, and that's why we do it through the whole state.